last conic section is revisiting something that we've looked at before in a different context, which is parabolas. So far we've only looked at things like y equals x squared, which was a parabola that opened up, y equals negative x squared, which is a parabola that opens down, but now we're going to look at what happens when we square our y value instead. So if I have x equals y squared, it's going to open right, and if it's x equals negative y squared, it opens left. The other important pieces of our parabola is we have our parabola with its vertex, then we have one focus, and something called the directrix. So I'm just going to put F for focus. This is called a directrix. I didn't leave enough room. Like the word direct, and then RIX, directrix. All right, and the distance between the focus and your vertex is C, like how we had defined C before, and the distance between your vertex and the directrix is also C. So for a parabola, we need to get it into vertex form. So we did a lot of work in second quarter with going to vertex form. So as a reminder, that's where we draw this dotted line, and I need there to be a 1 in front of the x squared, or y squared in this case, which I'm good. So then we complete the square. We've been doing this a lot, so I'm going to go a little bit faster than normal. So x minus 3 squared, what am I putting here? 9. But this is where we have to do the opposite. So instead of adding 9, we're going to subtract 9, and that's because of this dotted line. We're on the same side of the equal sign, which means I need to do the opposite operation. There is a way for me to do this alternatively, but that involves moving the 11 over, and then you get frustrated, so we're just going to do it this way. All right, 11 minus 9 is 2. So my equation is y equals x minus 3 squared plus 2. So since I have the x being squared, that means it's opening either up or down, and since in front of my parentheses is positive, that means it's opening up. Vertex is at 3, negative 2. So I can go ahead and plot that. 3, negative 2. And I know that it's going to open up. But I need to graph two other things, which is something called the focus and the directrix. So the formula for this is that A in my equation equals 1 over 4 C. C is my distance from my vertex to the focus and the vertex to the directrix. Or we could say C equals my focal length equals 1 over 4A. It has a reciprocal relationship, so it doesn't matter which of those we're setting equal. So since I started with an equation, I need to use the second formula I wrote. So what is in front of my parentheses is a 1, which means that A is 1. So when I substitute in my equation, I get C equals 1 over 4 times 1, which is just 1/4. You'll see 1/4 and 1/8 happen a lot. And that it's going to be easier for me to change this to a decimal. So that would be 0.25. So I always say that your curve hugs your focus. So my focus needs to be inside my parabola. And specifically, it's going to be 0.25 above my current vertex, and then my directrix is 0.25 below my vertex. So my focus, what's changing there? What's changing is my y value. So from my vertex, we had Do this similar to with ellipses and hyperbolas where we wrote our center. Here we're going to write our vertex. And when I look at my graph, what's changing? What's changing is my y value. So I need to put plus 2.5. So my y value is what's changing. So -2 plus 2.5 because it's above, the focus is above my vertex. And then my directrix, when it's a horizontal line, is going to be y equals, because the graph of a horizontal line is from the equation of y equals. And then that's going to be my y coordinate, because it's y. Okay, y coordinate. And now we're going to minus 0.25 because it is below my parabola. Okay, so if I simplified both of those, it would be 3 negative 1.75 and y equals negative 2.25. I really don't like mixed numbers, so let's just do decimals. So looking at the next one, what's different? It's x that's to the first power, not y, but we will proceed the same way. So draw your box. I do already have a 1 in front, so that's good. Y squared split in half, 7y, y, 7, 7. So x equals y plus 7 squared. What goes in my gaping hole? 49. But instead of adding 49, I'm going to subtract 49. So 45 minus 49 is -4. So in this case, my vertex is going to be -4, -7. Remember that what's inside is going to be opposite, and since inside I have my y, that means that inside value is giving me my y coordinate and the other one is my x coordinate. So maybe put a little star there. Since the y is what's being squared, it's going to open either right or left, and since it's a positive in front, that means it's going to open to the right. And you could write, like literally right, but so c equals 1 over 4a. So c equals 1 over 4. Once again, what do I have as my coefficient? 1. So I get 1/4. And we're going to use 0.25. You will see these all the time. Okay. So let's sketch our graph. My vertex is -4, -7. And my graph needs to open to the right. So that means my focus is going to be on the inside. Directrix is on the outside. These are decimals, so they're not going to be super precise. So what is changing from my vertex? The x value is what's changing. So my focus is going to be -4, and then I'm moving to the right, so I'm going to add 0.25. And then my directrix is x equals -4 minus 0.25. So my focus, when I simplify, is going to be -3.75, comma -7, and my directrix is going to be -4.25. Graphing those precisely is less important, but it is helpful to at least sketch where it-ish is going to be, because then you can know whether you're adding or subtracting. Alright, so let's look at this one. This one is different because you don't have the variable isolated on the left already. So I am going to make the choice that since my variable to the first power, y, is already positive, I'm going to move all the other things to the other side. So y equals negative 2x squared plus 12x minus 10. Basically, switch all your signs. Okay, and now remember when we did completing the square, we had to take out that negative 2. So this would be x squared minus 6x. And then on the other side of my dotted line, I'm going to be adding 2 times whatever is in my little box when I do that. Okay, first term, first box, split. So x, negative 3, negative 3. So bring down negative 2, x minus 3 squared. We need a 9, so that's going to be 9. And we have negative 10 plus 18 is 8. So y equals negative x minus 3 squared plus 8. Now, since it's x squared, it's going to open up or down, and it's negative, so it's going to open down. My vertex is 3, 8, and we need to find our focus. So my focus is c equals 1 over 4a. So c equals 1 over 4 times 2, which would be 1 over 8. Okay? Now, why didn't I do the negative? Because the negative is going to come in when I think about my graph. Okay? So I take care of the negative just by thinking about my graph. So 3 and 8, of course, is at the very top. And we're opening down. So that means my focus is going to be below my vertex, and my directrix is going to be above my vertex. Okay, so my focus, we take our vertex, 3 and 8, and what's changing for this? What is changing from my vertex is my y value. So where is it? My focus is below my vertex, so I'm going to subtract 1/8. Notice I didn't change that to a decimal because I'm being lazy, but you should type in the calculator and get me a decimal. Okay, thanks, bye. All right, my directrix is horizontal, so it's going to be y equals your y value, and my directrix is above the vertex, so we're going to add 1/8. Type it in the calculator and get me the decimal. For the last thing, I want to look at doing it when it is a fraction. So when it's a fraction, we start as normal. You get one of the variables by itself. Okay? And notice I'm going to be taking away 1/2 times whatever I get. So we haven't talked about factoring out a fraction. So factoring out a fraction, you're thinking half of what would give you 6. Well, that would be half of 12. The other way you can think about it is that we are multiplying the previous number by 2. You don't want to divide the number by 2. So that's the common mistake. So y equals 1/2 x squared split in half x 6. So x plus 6 squared, which is 36. So that would be 18 minus half of 36 would be 18, so plus 2. So x squared is, x is what's being squared, so this is going to open up. My vertex is negative 6, positive 2. And now we're looking at when I'm finding a focal length and my a is a fraction. Well, this one isn't such a bad fraction. So 1 over half of 4 would be 2. So c is 1/2 or 0.5, which is happier for me to graph. All right, negative 6, positive 2 for my vertex. We said the graph needs to open up. That was horrible. Okay, so then the focus is always on the inside. So about right there. That was a little too high, but I'm writing on a tablet. Don't judge. Okay, so my focus, what is changing is my y value because my focus is higher than my vertex, so -6, comma 2 plus 0.5. My directrix is y equals 2 minus 0.5. Okay, so we're using the graph to see whether I add or subtract. Okay, because on the graph I can tell the focus is above, so I need to add, and the directrix is below. So I need you to just try as best you can the other 3 graph questions. I'm going to post also with this video a picture of the key for you to check. But I just want you to take, don't take more than, say, 10 minutes on trying those, and then I'll post the key as pictures. For now, we're going to finish. Okay, what's the most important thing for writing equations? Graphing, Miss Vance. Okay, graphing. So my vertex is at origin. My focus is at -2, 0. So there's my vertex and there's my focus. So what have we talked about in terms of the shape of my graph? My parabola always hugs my focus. So I know the focus has to be the inside. And that means that this equation is going to be what am I saying, y'all? It's a hard day. Okay. X, because it's opening sideways, equals y something squared. Okay. So my vertex is 0, 0. So that's kind of boring when I plug it in. Do I really need it? No, but I want to show that we thought about it. And then I need to get A. So to get A, I'm going to use A equals 1 over 4C. C is the distance from your vertex to your focus. How far is the vertex to the focus? That's 2 units. So C is 1 over 4 times 2. So A is 1 over 8. Now we're going to use our brain, y'all. Use your brain. Look at it. It opens to the left. So I need to put a negative because it's opening to the left. If it opened to the right, it would just be 1/8. Draw your pictures. Draw them. Don't do it in your head. Okay, once again, I have vertex at origin. Directrix is at x equals 2. So my directrix is at x equals 2. So I'm going to call that D. And then there's my vertex. So my parabola is not going to cross my directrix, which means my parabola is, once again, going to be opening left. My center, why do I keep saying center? I know why, because we've been talking about centers. My vertex is at 0, 0. Since it opens sideways, it's x equals y something squared. We said vertex is 0, 0. Once again, I don't need that, but I want to show we're thinking about it. To get my A, we're going to do A equals 1 over 4C. C is how far, in this case, the directrix is from the vertex, which is 2 units. So 4 times 2 gives us 1/8. And once again, it's opening to the left, so we're going to put negative 1 over 8. Vertex at -1, 3. And focus at -1, 0. Okay, so I have my vertex, I have my focus. Okay, the vertex, the parabola hugs the focus. Focus needs to be on the inside. Okay, so this one is vertical. It's opening down, so that means we're going to have y equals x squared. My vertex is -1, 3, so it's going to be x plus 1 plus 3. And I need to find my A value. So A equals 1 over 4C. C is how far my vertex and my focus are apart, which is going to be 3 units. So that would be 1 over 12. So I put that in there. And then I use my eyes. It's opening down, which means that the 1 over 12 needs to be negative. Last one for equations, we have a focus at 2, 2, and directrix at x equals negative 6. 1, 2, 3, 4, 5, 6. Okay, so what we need to remember when we're dealing with focus and directrix is I need my vertex. Your vertex is going to be exactly in between those two. So I can tell it needs to be in line with the focus, so my y value is definitely going to be 2. And then halfway between 2 and negative 6 is going to be negative 2. You can just count it. Nothing wrong with counting, okay? So my vertex is going to be at negative 2, 2. And I have to decide which way it opens. Well, it's never going to cross my directrix, and it hugs the focus. So this one is going to open to the right. So it's going to be x equals something y squared. We have this. Now be really, really, really careful, because since it's a horizontal, that means what goes inside is my y value. So minus 2, and then at the end, minus 2. Then we have to find a equals 1 over 4c. So a equals 1 over 4. How far is my vertex to the focus, or my vertex to the directrix? That's a total distance of 4. So a is 1 over 16. And it opens to the right, so I don't have to worry about any sort of negatives.